Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down in detail so that you can learn how to Sudoku. I'm armed today with my brain juice, so we should be pretty good here. Today's puzzle, very easy puzzle, is called Australian Cities, Odd Platform, and it's by Pagedo or Pagido. I'm not sure how to pronounce it. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. The mainland coast outline points, the gray circles, contain odd digits. So all these gray circles, interesting. I don't know why they're separate, but all these gray circles are essentially odd digits. Tasmania. The gray square contains an even digit. So this is an even digit. And as you can tell, this is, or I don't know if you, maybe you're not as familiar. I think my audience is pretty knowledgeable about geography. This is obviously an outline of Australia. And this is Tasmania here. And this Tasmania is an even digit. And this whole border of Australia is a region sum line. And that specifically is called box borders divide the coasts, the blue region sum lines, into segments with the same sum. So basically, these 3 digits is equal to the sum of these 4 digits, which is equal to the sum of these 3 digits, which is equal to the sum of these 3 digits, etc., etc. Yeah. And that's how region sum lines work. We also have cells joined by an x sum to 10. So for example, if this was a 3, this would have to be a 7 to add up to 10, because we know that these 2 digits add up to 10. And cells joined by a v sum to 5. So for example, if this was a 3, this would have to be a 2 to add up to 5. And that's how x's and v's work. We also have cells joined by a city. I guess these are the major cities in Australia. That's pretty cool. So these are all the major cities of Australia here too. I think Sydney is one of these two. I'm not sure which one. Melbourne, I believe, would be here. This is like Hobart or something like that. Anyways, the cells joined by a white city, or city, which is a white dot, are consecutive, and not all x's, v's, or dots are given. So as an example, if this were, say, a 3, this would have to be a 2 or 4 to make sure that these are consecutive. And that's how these white dots, which we are also known as crop key dots, work. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so what should we do? Well, these are consecutive with odd digits here, right? These 2 cells are specifically consecutive with a next to a circle cell. So these must be even digits, and we're going to color the odd digits all as red and all the even digits as blue. That's just basically personal preference. So this must be even, this must be even, this must be even, so this has to be odd because it's consecutive with an even digit. Actually, wait, is that? Oh, that is right, though. If this is odd, so it has to add up with an even digit to add up to an odd digit, right? So this must be even. Therefore, this is odd. This is even here. These both must be odd, because if you have an odd digit with another odd digit, it must add up to 10, right? To add up to an even digit, an odd digit must add up with an odd digit to add up to 10. Okay, this is even, and this is even, right? Because again, like I said, to add up to an odd digit, you need an odd and an even digit, and this one's odd. To have consecutive digits, this has to be even if it's next to an odd digit. But to add up to an even digit, you need two odds or two evens. Therefore, this must be odd. And we have 5 odds in row 8, which eliminates odd digits from the rest of the row. So these are all even, and this is even. We now have 4 even digits in this box, so the rest of them must be odd. So this is odd, and this is odd. We know that the sum has to be odd. And the reason why we know that is because these two are even, and this one's an odd. And if you have two evens, they always add up to an even. But if you have an even and an odd digit added together, you always get an odd digit. So this has to be specifically, the sum has to be an odd number. Okay. Therefore, in this box, we have two odd digits, but we know it must add up to an odd number. So it must need another odd, because otherwise it would be even if we added an even digit to it. Now in row 7, we have two digits that are separated by a white crop key dot. One of them has to be even, and one of them has to be odd, because they're always, you cannot have two even digits which are consecutive with each other, and you can't have two odd digits which are consecutive with each other. Excuse me. Therefore, one of these is odd and one is even. Well, we already have 4 odds in the row, so that means we now have 5 where we know we have 5 cells which have to be odd. Therefore, this cannot be odd, it has to be even. And again, an even and an odd digit must add it to an odd number. So this must be odd. Oh, we couldn't also, yeah, figure that out. This is one thing we know. Okay, so if all of these were odd digits, there are 5 odd digits here, right? So, or sorry, there would be 5 odd digits, and therefore it would have to be all 5 odd digits. So that'd be 1, 9, 3, 7, and 5, which is 25. But if you try to get 3 digits and you add them together to add up to what's the maximum, it's 7, 8, and 9, 24. So if you had all of these be odd digits, it would not work, because they would have to add up to 25, and then 3 digits could not add up to the same value. Therefore, these are both even, because we need an odd value again, and we're not sure exactly what that is. We do know that the value is at most 19, because we have 2 digits here adding up to 10 with an odd digit. So it's 11, 13, 15, 17, or 19. But we need 5 digits adding up to it. So that means it's at least 15, 17, or 19. Because the minimum amount you could have with 5 unique digits is 1, 2, 3, 4, 5. Which is obviously 15 at least. So this has to be 5, 7, or 9. And actually, this has to be the same digit as this digit, because this adds up to 10. This adds up to 10. These are the same sum, no matter what. So this has to be exactly the same value. So we'll mark that as an A, I guess. This is A, this is A, so A is one of these 3. It's either 15, 17, or 19. This must be odd too, because these two are odd. And to add up to an odd digit, you have to have 3 odds instead of 2 odds and an even. Oh, wait, this is not the same. This is actually 4 digits. My apologies. This is not actually the same value. Oops. So this A is actually not the same value. Apologies for that. Sometimes be careful about that. I've done it actually not multiple times, but a decent amount of times. So this cannot be 9. This could actually be 1, 3, or 5, or 7. We don't know. And this is 5, 7, or 9. Therefore, these 3 digits have to add up are odd, and it has another digit added to it, and it still has to be odd, right? So these 3 digits are odd. It has to add with an even digit to add up to an odd. So this is even, this is odd. And this has to be 2, 4, or 6 at most. And the reason why we know that is these 2 digits must add up to what this digit is. And that's also a reason why we know that these digits are different. So these digits are specifically 4, 6, or 8. Because those are the only digits that can be consecutive with 5, 7, or 9. Interesting. These 2 are consecutive, and this is at most a 4. That means this is 2 or 4. This is 1 or 3. Can this ever be 2? If this is 2, this is 3. This is at most 8. So that would mean this is 13 at most. So this can never be 2. Because we know we have 5 digits adding up to the same sum. And that must be at minimum 15, as we stated before. So this cannot be 2. This has to be a 4. Which makes this a 1. This is either 3 or 5. This obviously can't be a 4. So this actually has to be... This adds up to either 15 or 17. It can never add up to 19. So this can never be 9. So this is 5 or 7. Therefore, this can never be 19. So this can never be a 7 here. This is 1, 3, or 5. With 2, 4, 6 could add up to 17 there. Because remember, this adds up to 10. And that's the reason why we know this adds up to whatever this digit is. Because this adds up to 10 also. We have one of these is even and one of these is odd. Let's see. So these 5 digits must add up to at least 15, but it could be 17. And if it's either only 15 or 17. Either way, if you have 15, it's 1, 2, 3, 4, 5. If it's 17, it could be 1, 2, 3, 4, 7, or 1, 2, 3, 5, 6. Either way, you always have a 1, and you always have 2 and 3 on this region sum line. That's 5 digits. So 2 has to be one of these cells. 3 also has to be one of these cells. We have a 1 here. Where can the 1 be in this region sum line? It has to be one of these 2 cells, right? It cannot be here, and it can't be the even digit. 3 is one of these odd digits here. So 3 has to be one of these 2. Because one of these is 3. One of these is 2. 2 cannot be here. So 2 has to be one of these 2. We're not sure which. And the 3 could be any of these 4 remaining cells. It can't be the even cell, though. Okay. Can this ever be 15 here? If this is 15, this has to be a 5. But then this forces this to be 4, 3, and 8 to add up to 15. And 8's not consecutive with 5. So this can never be 15. It has to be 17. So this is 17, which means this is 4, 5, and 8 to add up to 17. This is 17. This cannot be 3 and 7 to add up to 10, so this can never be 3, which forces this to be a 3. That's 3 in the corner. We celebrate because we know what the sum is for the region sum line. This is 17. These two add up to... this is 2 or 4 here. And these are two odd digits adding up to 10. They have to be 1 and 9. Because we already said 7 has to be here. Therefore, 3 cannot be added up with another odd digit. 5 doesn't add up with another odd digit, so this can't be 5. Which means this sum of 5 digits can never have 1, 3, and 5 in it. So it's 1, 2, 3, 4, and 7. So this has to be a 3, 7 pair. So this is 3 and 7, this is 3 and 7, and this has to be 2 and 4 then. Okay. This obviously can't be 1, this can't be 1 and 9, this has to be 3 and 7, adding up to 10, because that's the only odd digits now that can add up to 10 that are not 1 and 9. This has to be a 5, because we have a 1, 9 pair and a 3, 7 pair in the same row. And this must be a 2 to add up to 17 with 3, 5, and 7. So this is 2. Therefore, this even digit, it has to add up to 5, so it would have been either 2 or 4. It cannot be 2, therefore it must be 4. This has to be a 1. 2 is only consecutive with 1 or 3, and then we already have a 3, 7 pair in the same box. So this cannot be 3. This has to be 1 then. So this is 2, 1, and 4. What else do we have? Oh, we have 2 odd digits here. This has to be odd. I don't know if I colored that before. I think I did. I feel like I did, but I don't know. This cannot be a 1, 4 pair because 1 cannot be here. Therefore, this must be 3 and 2. So this is obviously not a 2. This can't be a 3. This can't be a 3, so this must be 7, which makes this a 3. So this can't be 3. Well, where is the 3? We know the 3 has to be on this region sum line because the minimum, the only possible values are 1, 2, 3, 4, 7, and 1, 2, 3, 5, 6, and we need a 3 there. So this is a 3 because it's the only place possible for it, and this must be a 1. So we know this is odd, and now we have 3 odds and 1 even in this 5 cell sum, and we need another even digit to add up to an odd value. So this is specifically either 4, 7, or it's 5, 6. So this would be 5, and that would be 6 if that's the case. This is 3. These digits are all odd, and they must add up to 17, which they do, which is 3, 5, and 9. This can't be 3, though. That means the remaining digits here are 6 and 8. This is 6 and 8. This must be then, because of the 6, 8 pair in the box, this must be a 2 or 4, because 6 and 8 are eliminated. This can't be 4 because of this 4, so this must be a 2, which makes this a 4. This 4 means this has to be 2, which makes that a 4. The remaining digits here are 6 and 9, but we're not sure which one's which. And the remaining digits in column in these two cells, because of the 6, 9 pair in the box, has to be 5 and 8. So this is 5 and 8, this is 5 and 8. These two digits must add up to 14. And there's only 2 odd digits that can do that, which is 5 and 9. The other ones would be even. If you had 6 and 8, that would work. But 5 and 9 is only consecutive with 4, 6, and 8. But 4 is not possible, so this must be 6 or 8. We know in this box, in this upper left box, 1 cannot be here, 1 cannot be here, 1 can't be here, and 1 can't be here. So 1 has to be here. So this is an odd. The remaining digits here are 6, 8, and 9. The remaining digits here are 4, 6, and 8. And the remaining digits here are 1, 2, and 7. Well, this can't be 2 because of this 2. This can't be 1 because of this 1. 3, 5, and 9. 9 would only be consecutive with 8, and 8 is already in that row. So this cannot be 9 then. 3 and 5 can be consecutive with 2, 4, or 6. That's fine. Let's see, what else do we have? This can't be 8 because of the 5, 8 pair in the column, so this has to be a 6, which forces this to be 8. 8 is only consecutive with 1 or 9, so this must be a 9, which makes this a 1. Now we know in the rest of the cells in column 7 have to be 1, 2, and 6, and the rest of the cells in column 8 have to be 3, 7, and 9. Well, this can't be 1 here. These digits must add up to 15, or sorry, 17, but we don't know which ones those are. Let's see. These are 1 through 4 because they add up to 5. These can't be 1 or 3, so this has to be an even, which means this must be an odd digit. So this is 1 or 3. And you cannot have a 5 here because of the 5 already in the row. Therefore, this is consecutive with 2 or 4. It must be also odd, and it's 1 or 3. So now we have a 1, 3, 1, 3 pair in row 5, which eliminates 1 and 3 in the rest of the row. This can't be 1. This can't be 3. We have a 2, 6, 2, 6 pair in column 7, which eliminates 2 and 6 from the rest of the column. So this can't be 2 or 6. It has to be a 1. Okay. We know 8 can't be here. We know 8 can't be here. So in the middle box, we know 8 has to be one of these 3 cells, which means 8 has to be one of these 3 cells in this box here. This can't be 5 because of this 5, so this must be a 9, which is only consecutive with 8. This 9 means this has to be a 5. This 5 means this can't be 5, so this is 7, and this must be 4 to add up to 17 with the remaining digits in the region sum line. This can't be 5 because of this 5, so this is 8, which makes that a 5. Because this can't be 7, which makes this a 2. This can't be 2. This 2 means this can't be 2, so this makes this a 4. 4 adds up with 1 to add up to 5, so this is 1, this is 3. This can no longer be 4 here, so these can't be 4. For the 5 in this box in the left side, we know it can't be here, we know it can't be here, so 5 has to be one of these 3 cells. Therefore, these 3 cells add up to 17, and then that means the 2 other cells besides the 5 has to add up to 12, because 17 minus 5 is 12. So it's either 3, 9, 5, 7, or 4, 8, and we're not sure. So if it's 4, 8, 8 has to be here, and 4 has to be here. But if it's 3, 5, 9, this can't be 5 here. So 5 is one of these 2. And 3 cannot be here, so this would have to be the 9 if this is 3, 5, 9. So this would be 3, 5, 9, 3, 5, 9. Oh, it cannot be 5 and 7. This can't be 4. This is 8. It can't be 3, 5, 7. It can't be 5 and 7 because 5 is already on the line. And you can't have 5, 5, 7. So it's either 3, 4, 9. No, 5, 4, 9. Or 5, 4, 8. Apologies. Or 3, 5, and 9. Either way, 5 is one of these two cells. This cannot be 9 here. This can't be 9 here because of the 9 in the row, so this is 6, which makes that 9. The remaining digits in row 1 are 4, 6, and 8. They're all, oh, so these are all odd digits, and these are even digits. Well, yeah, the remaining digits in row 1 are all even. Therefore, this is not 2, 4, 8. It has to be a 6, and this has to specifically be 4, 8. And the remaining cells in row 2 have to be odd. So this is odd and this is odd. Well, this can't be 1, 3, 7, or 9, so this is a 5, which makes this a 7. This 5 means this can't be 5. It has to be 3. This can't be a 6 because of this 6, so this must be 2. This can't be 2, so this is 6, which makes that a 2. These are both evens. This is an odd. All 3 of these are odd. This can't be 6, so it must be 8. None of these can be, this can't be 4, 8, so it must be 6. That makes this a 4. This can't be 3. This is 5 or 9. This has to be a 9 because that's the only digit remaining in the box, which means this can't be 9. This has to be a 5, which makes this a 9. This can't be 1 because of this one, so this is 7, which makes that a 1. These are odd. And this is even. We know where the 8 has to be now. Cannot be here, cannot be here. It has to be here, which is an 8 and an even, which means the last digit in the column is odd. This already has 4 evens here. This must be odd then. And it's a 9. So this cannot be 9 here. The remaining digits in these... Okay, so the remaining digit here is a 5. The remaining digits here are 6 and 7. This can't be 6, so this must be 7, which makes that a 6, which is the even. This is an odd. This can't be 7, so it's 3 or 9. This is an even because it cannot be a 9. It's only 6 or 8. These two digits have to both be even because we already have 5 odds in the row. And it's 2 or 6 specifically. This can't be 2, so this makes this a 6, which makes this a 2. We now actually have 8 2s, which allows us to know where the last 2 is. It has to be here. So this is a 2. Therefore, it's even. This cannot be 5 anymore. Where is the 5 in column 1? It has to be here. So this is a 5. This is also an odd digit, and it has to be 3 or 7. But it can't be 3 because of that 3, so it must be 7, which makes this 3, which makes that 9, which makes that 7. This cannot be an odd digit because we have 5 odd digits in the column, so this must be even. So it's 6 or 8. We're going to remove the outside. This has to be a 3-4 pair because those are the only digits remaining in the row. This is 6, 8, or 9. And what else do we have? This can't be 7 because of this 7, so this must be 3, which makes this 7. This 3 means this can't be 3, so this is 4, which makes this 3. So we know this is 3, 5, and 9 to add up to 17. Therefore, this is even, and this is odd. We now have 5 odds in column 1, so this must be even, and this must be odd, which forces this to be the 9. This can't be 9. This is the 9. This can't be 4, so this is 8, which makes that 4. This can't be 6 or 9, so this is 8, which makes that 6, which makes that 8, and therefore this is 6. And that's how you solve it. Actually not that easy, but still, you know, very approachable. Fun puzzle, actually. Like, very good use of geography to enliven the Sudoku. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.